Time. It dictates our lives, weaving through every moment and every action. It measures our every moment, from the smallest seconds to the grandest years. From the ticking of a clock to the rising and setting of the sun, time seems to be the one constant in our ever-changing universe. It is the silent witness to the passage of our lives. But what if I told you that time, as we know it, might be an illusion? A construct of our minds, rather than a fundamental aspect of reality. This is a question that has puzzled philosophers and scientists for centuries, and it's a question we're going to explore together. From ancient thinkers to modern physicists, the nature of time has always been a profound mystery. Our perception of time is so ingrained in our experience that it's hard to imagine it not existing. We live by the clock, plan our days and mark our milestones. We remember the past, experience the present, and anticipate the future. These three dimensions of time shape our reality and our identity. This linear progression of time seems fundamental to our reality. It gives structure to our lives and a sense of continuity. Yet as we delve into the realms of physics, cosmology, and even our own consciousness, we begin to uncover a more complex and mysterious picture of time. It is not as straightforward as it seems. Throughout history, humankind has sought to understand and measure time. From the earliest days, we have been fascinated by its passage. Ancient civilizations observed the cycles of the heavens, constructing sundials and calendars to track the passage of days, months, and years. These tools were crucial for their survival and progress. These early attempts to quantify time were essential for agriculture, navigation, and the organization of society. They allowed people to predict seasons, navigate the seas, and coordinate activities. The invention of mechanical clocks further cemented our perception of time as a linear and measurable entity. It brought precision and regularity to our daily lives. However, the advent of modern physics, particularly Einstein's theory of relativity, shattered our classical view of time. It introduced a new understanding of time as something relative and dynamic. We began to see time not as an absolute and unchanging entity, but as a relative and flexible aspect of the universe, intricately woven with space itself. This was a revolutionary shift in our understanding. This revelation opened up new avenues of exploration, leading to mind-bending concepts like the block universe and the possibility of time travel. The future of our understanding of time is as boundless as time itself. Time is the silent orchestrator of our lives, an invisible force that shapes our existence in ways we often take for granted. It governs our daily routines, our long-term goals, and our understanding of the world around us. From the moment we wake up to the time we go to bed, time dictates our actions and decisions. We schedule our days around the clock, measure our progress in years, and celebrate milestones based on the passage of time. Birthdays, anniversaries, graduations, all are markers of time's relentless march forward. Our very language is steeped in temporal concepts, with verbs conjugating to express past, present, and future actions. This linguistic structure reflects our deep-seated need to organize our experiences within the framework of time. Beyond our individual lives, time plays a crucial role in our understanding of the cosmos. The night sky, with its myriad stars and galaxies, is a testament to the vastness of time and space. Cosmologists study the evolution of the universe from the Big Bang to the present day, unraveling the vast timeline of cosmic events. They seek to understand how the universe has changed and evolved over billions of years. Astrophysicists observe distant stars and galaxies, their light carrying information about events that happened millions, even billions of years ago. This light is a time capsule, offering glimpses into the distant past. Time, in a cosmological sense, allows us to piece together the history of the universe and glimpse into its distant past. It is a tool that helps us understand the sequence of events that have shaped the cosmos. The concept of time is also essential for our understanding of cause and effect. It provides a framework within which we can understand how one event leads to another. We intuitively understand that events happen in a particular order, that causes precede their effects. This understanding is fundamental to our perception of reality. This fundamental principle of causality underpins our scientific inquiry and our ability to make sense of the world. Without it, our scientific endeavors would be aimless and chaotic. Without a notion of time, the concept of cause and effect would become meaningless, and our understanding of the universe would be fundamentally altered. Our entire perception of reality would be thrown into disarray. But what if this seemingly fundamental aspect of reality is not what it seems? What if our understanding of time is merely a construct, a way for our minds to make sense of the world? What if our perception of time as a flowing river, carrying us from the past through the present and into the future, is merely an illusion? This question challenges our deepest assumptions about the nature of reality. This is the intriguing possibility that emerges when we delve into the depths of modern physics and confront the profound implications of Einstein's theory of relativity. It suggests that time may not be as straightforward as we once thought, opening up new realms of understanding and exploration. In the early 20th century, Albert Einstein, a young physicist with a revolutionary idea, forever changed our understanding of time. His groundbreaking work challenged the very foundations of classical physics and introduced concepts that were both mind-bending and transformative. His theory of relativity, expressed in the famous equation EMC2, unveiled a universe where time is not absolute, but relative. This equation, simple yet profound, encapsulated the relationship between energy, mass, and the speed of light, and hinted at the deeper, interconnected nature of the cosmos. Time, Einstein revealed, is not a universal metronome ticking at the same rate for everyone everywhere. Instead, it is a variable entity, influenced by factors such as speed and gravity, making it a more complex and dynamic aspect of our universe. Instead, it is intertwined with space, forming a four-dimensional fabric known as space-time. This fabric can be warped and stretched by massive objects, leading to phenomena that defy our everyday experiences and intuitions. One of the most startling consequences of Einstein's theory is time dilation. This phenomenon reveals that time can stretch or compress depending on the relative motion of observers and the strength of gravitational fields they experience. Time dilation means that time passes at different rates depending on relative motion and gravitational fields. For instance, an astronaut traveling at high speeds would age more slowly compared to someone on Earth. The faster you move through space, the slower time passes for you relative to someone stationary. This effect, though imperceptible at everyday speeds, becomes significant at velocities approaching the speed of light. Similarly, time slows down in stronger gravitational fields. Near a massive object like a black hole, time can slow to a crawl, illustrating the profound impact gravity has on the flow of time. Imagine two identical clocks, one on Earth and one on a spaceship traveling at a significant fraction of the speed of light. The clock on the spaceship would tick more slowly, demonstrating the tangible effects of time dilation. According to Einstein's theory, time would pass slightly slower for the clock on the speeding spaceship compared to the clock on Earth. This difference, though small at first, would accumulate over long periods, leading to noticeable discrepancies. This difference in time, though seemingly minuscule at everyday speeds, becomes increasingly significant as objects approach the speed of light. At such extreme velocities, time dilation can lead to dramatic differences in the passage of time. The implications of time dilation are profound. It challenges our conventional understanding of time as a constant and unchanging backdrop, revealing a more fluid and dynamic reality. It means that time is not a rigid, unchanging framework upon which the universe unfolds. Instead, it is a flexible, malleable entity that can be stretched and compressed by the forces of nature. Instead, time is flexible, malleable, and intimately connected to the observer's frame of reference. This realization forces us to rethink our place in the cosmos and the very nature of reality itself. This realization opened up a Pandora's box of possibilities, challenging our deepest intuitions about the nature of reality. It invites us to explore a universe where time is not what we once thought, but something far more mysterious and wondrous. If you enjoyed this exploration of time, don't forget to subscribe to our channel for more fascinating insights into the mysteries of the universe. Thank you for watching.